Hello all. Today we'll be discussing about this object definition language. This ODL is used to create an object database schema. Okay, so suppose we have all these concepts that can be used to create an object database schema using this ODL. So as you can see, the ODL is designed to support the semantic constructs of the ODMG object model, and it is independent of any programming language. And its main use is to create object specifications, which means classes and inheritances. Okay, and hence ODL is not a programming language. The user can specify a database schema in ODL independently of any programming language and use the specific language bindings to specify how ODL constructs can be mapped to constructs in specific programming language like C++, Java, etc. And ODL is not used for database manipulation. So let's see one example, that is a class with key and extent, and a class definition with extent and key and more elaborate attributes. Still this is relatively straightforward, and this is one possible set of ODL class definitions for this university database. And in general, there may be several possible mappings from an object schema diagram or an ER diagram to ODL classes. And we know that the entity types are mapped into ODL classes. Okay, entity types are mapped to ODL classes, and inheritance is done using the keyword extends. And there is no direct way to map categories, that is union types, or to do multiple inheritance. So here we have a class person, and that extent persons and key SSN. So here SSN is defined as the key attribute, and it has several other attributes. And there is an operation, that is age also. And we have another example, that is as we know extends, here we have an extends relationship that is used for this inheritance. And also we note that we have inverse here. So by specifying this inverses, the database system can maintain the referential integrity of the relationship automatically. Okay. So here the class faculty that extends person. Okay. So this faculty is a class, and that extends person is defined earlier, and that extend faculty. Okay. And given these attributes, that is rank, salary and phone number. And here we have relationship department works in, and there is inverse, and department has facility, and a set grad student then advises inverse again, and this inverse is used to maintain the referential integrity. So in addition to these attributes and relationships, we can also include operations in object type specifications, that is class specifications. And for each object type can have a number of operation signatures, and which specify the operation name, its argument types, and its return value if applicable. Okay. Operation names are unique within each object type, but they can be overloaded by having the same operation name appear in distinct object types. Okay. The operation signature can also specify the names of exceptions that can occur during operation execution. And in the previous example, we didn't use the concept of interface, used only classes. We now utilize a different example that is used to illustrate interfaces and interface behavior inheritance. Okay. So here we are specifying an interface that is a shape and with operations to calculate the perimeter of this different geometrical objects, and we have defined this class triangle and that inherits properties of this shape extent triangles. Okay. And also we have some attributes here. So here this shape is an interface and it is non-instantiable. That is, no objects can be created based on this interface directly. So however, objects of type rectangle, triangle or circle can be created, and these objects inherit all the operations of the shape interface. And note that with interface inheritance, only operations are inherited, not properties, that is attributes or relationships. And hence, if a property is needed in the inheriting class, it must be repeated in the class definition as with the reference point attribute. Okay. So if we need to have this properties, then that should be defined inside as with reference point attribute. And notice that inherited operations can have different implementations in each class. For example, the implementation of for example, area or perimeter operations may be different for rectangle, triangle and circle. Okay. Next is object database conceptual design. So we'll be discussing about differences between conceptual design of um, ODB and RDB, that is object database versus relational database. So the main differences are listed here, that is the relationships are handled differently in both and inheritance is handled differently and operations in this ODB are expressed early on since they are part of the class specification. So we'll be discussing each one. So how relationships are handled. So one of the main differences between ODB and RDB design is how relationships are handled. So in ODB, relationships are typically handled by having relationship properties or reference attributes that include object identifiers of the related objects, and these can be considered as OID references to the related objects. Both single references and collections of references are allowed. Okay. References for a binary relationship can be declared in a single direction or in both directions depending on the types of access specified. That is, if declared in both directions, they may be specified as inverse of one another, thus enforcing ODB equivalent of the relational referential integrity constraint. And in RDB, relationships among tuples, that is records, are specified by attributes with matching values. Okay, these can be considered as value references and are specified via foreign keys. Okay, which are values of primary key attributes repeated in tuples of the referencing relation, that we know the definition. These are limited to being single valued in each record because multi-valued attributes are not permitted in the basic relational model. Thus, this M to N relationships must be represented not directly but as a separate relation, that is table. And mapping binary relationships that contain attributes is not straightforward in ODBs, since the designer must choose in which direction the attributes should be included. If the attributes are included in each directions, then redundancy in storage will exist and may lead to inconsistent data. So hence it is sometimes preferable to use the relational approach of creating a separate table by creating a separate class to represent the relationship. This approach can also be used for n-ary relationships with degree n greater than 2. And another major difference between ODB and RDB design is how inheritance is handled. In ODB, these structures are built into the model. So the mapping is achieved by using the inheritance constructs such as this derived and extends. In relational design, there are several options to choose from since no built-in construct exists for inheritance in the basic relational model. And it is important to note that object relational and extended relational systems are adding features to model these constraints directly as well as to include operation specifications in abstract data types. And another major difference is that it is necessary in the case of between this ODB and RDB is the specification of operations. In ODB design, it is necessary to specify the operations early on in the design since they are part of the class specifications. So it is important to specify operations during the design phase for all types of databases. The design of operations may be delayed in RDB. Okay, this may be delayed in RDB design as it is not strictly required until the implementation phase. Okay, so this specifications may be delayed until implementation. And there is a philosophical difference between the relational model and the object model of data in terms of behavioral specifications. So the relational model does not mandate the database designers to predefine a set of valid behaviors or operations, whereas this is a requirement in the object model. One of the claimed advantages of the relational model is the support of ad hoc queries and transactions, whereas these are against the principle of encapsulation. Okay, so these are the main differences between conceptual design of ODB and RDB. Okay, thank you.